Welcome to this live stage session of Industrial Biotechnology course. So, I welcome all the students for their questions, and I received 5 questions in the Excel sheet, and I try to give the answer one after another. First question that is asked, that is the biotechnology industry are keep on changing new product and technology are coming in how we should aware of current advances in the industry. I hope this is quite relevant question that we have, that that it is, in fact it is that new product is usually come from the R&D activities. Am I right? The research and development, that different laboratories, different R&D labs, they develop new products, and then industry they take it and finally they implement that. Now, that kind of information we can have from the industrial profile, because we have lot of biotechnology industry as per India is concerned. As for example, we have Biocon, we have Santa Biotech, we have we have lot of other companies that we have. So, Reddy's lab. So, lot of companies we have. If you see the company's profile, and they regularly they update it, what are the new products they are launching. So, those kind of information can be generated from that, and other avenue through which this information can be raised by, one is your journal, and I can refer the journal that Chemical Week that is published in India, and this journal will give you all the chemicals, not only biochemicals, all the chemicals that we have in the market. So, you can, if you go through that particular journals, that you will get the information what is the new bioproducts is coming. If there are any new products, they will come in this particular journals. Plus, if you go through the different other journals like Science, like Cell, they usually publish the research paper, and this journal, why they are famous? They are always work with some kind of innovative type of processes and the research work that is going on. So, that also give you some information what are the recent the research activities are going on, what is the new products we are looking for, and all the information like this. And another information I can tell you, that is Department of Biotechnology, the DBT website in India. If you go through the website, there also you will find that what are the new project is coming, what are the new technology has been developed. All this information can be seen from the Department of Biotechnology website. I hope these are the these are the places from where you can see that what are the new products is coming out in the area of biotechnology, particularly industrial biotechnology. Now, second question that is raised by the Krishna Reddy, who is a student, that his question was that I would like to know the techniques for finding out the enzyme activity. Now, this is a quite relevant question that we have. Now, enzyme activities, as you know, that that usually that is expressed as that what you call cattle. This is the cattle. Cattle means that one cattle means 1 mole of substrate degraded or product form per second. This is one cattle stands for. Now how you say the enzyme activity? Enzyme activity moles of substrate converted per unit time. That means this is equal to nothing but what you can say that that rate of the reaction that we have into the reaction volume. Now, if you look at the rate, how you write the rate? Rate is the suppose A is the substrate A to B. Suppose this is the conversion. Then I can write this is Ca dCA by dt. Am I right? This is into reaction volume. So, this is what is Ca? Ca is the concentration. How we express that? This is moles of A per unit volume. Am I right? And this unit time unit what? This is time. So, into the reaction volume. So, what will happen? This volume and this volume will cancel. So, what we will be having here? Moles of A per unit time. Am I right? I hope it is very clear to you that how the activity of the enzyme can be expressed. Now, let me do little bit elaboration on that. That I can give the example of glucose oxidase. Glucose oxidase is kind of enzyme that is used for the analytical purpose, for the determination of glucose concentration. Because glucose concentration normally in the fermentation broth we estimate by DNS method, dinitrosalicylic acid method, but this method has the limitations. Why it is limitation? Because this determines the reducing sugar concentration. This doesn't tell us about exactly how much glucose is present specifically. Now, specifically if we talk about the glucose estimation, we go for glucose oxidase method. And this glucose oxidase method, how it looks? It is like this: the beta D glucose plus oxygen plus water in presence of glucose oxidase it will give D-glucono (1,5) lactone plus H2O2. Now, H2O2 is the strong oxidizing agent. Am I right? So, what you required, this H2O2 further it is supposed to be degraded, otherwise the activity of the enzyme will be lost, and then this is O dianicidin if you have, then in presence of peroxidase enzyme it gives the ortho dianicidin. So, this is oxidized form. We by in the spectrophotometer we can find out that what is the concentration of this in the final product. Now, 1 unit of glucose oxidase is the enzyme is that if you write 1 unit of glucose oxidase enzyme will oxidize 1 micromole of beta D glucose to beta gluconolactone and H2O2 per minute at pH 5.1 35 degree centigrade. This is how it can be done, but we can convert it to the kilocat. But this unit is little bit old unit. This is not a new unit. This is previously we use this estimation process that micromole of glucose degraded. Am I right? Glucose degraded per minute. Okay. This initially we used to do that previously. Now, it has been changed to cattle. The present estimation process is the cattle. I hope it is clear that that how the enzyme activity can be determined. Then another question he raised, that what is the scope of industrial biotechnology in India? That is the one very vital question that we have. Now, scope of the biotechnology industry is very vital, because during my presentation I try to make a very clear cut difference between the chemical and the biochemical process. And I told you that chemical process, what is happening, if as your product changes, your substrate also changes. But in biochemical process, same substrate can produce n number of products. What we do, we change the organism. The different organism can lead to the, I can give the example, glucose can produce citric acid in presence of Aspergillus niger. Now, if you can see the glucose in presence of Saccharomyces cerevisiae, under anaerobic condition it produces the ethanol. So, like this same substrate we can produce different type of products. So, now that is why we have a tremendous opportunity in India, and it has two different there are different sectors where the industrial biotechnology product has been marketed. One is for the production of oxychemicals. Now, what are the oxychemicals we have? As for example, ethanol, alcohol industry. In India, we have more than 200 distilleries. We have that so we have tremendous opportunity we have. Then we have another product that we have citric acid. We have lactic acid. So, all this produced in the industry. Now, there I told you in India we have more than 200 distillery. Citric acid industry, citric acid produced the company like Citurgia Biochemicals. Citurgia Biochemicals. It can be also produced by Citrate India. Citrate India, it can produce. So, that so if you look at the vaccine, that different type of vaccine also it can be produced, like vaccine. I can give the example of hepatitis B. It is produced by Santa Biotech. I can give the example of antibiotics. The one of the very famous industry that we have, that we call it is Sarabhai Chemicals. Now, Sarabhai Chemicals, this is they produce penicillin. So, that like this we have different type of other products we have, like hormones, we have the antibiotics like streptomycin, kanamycin, all the different products can be produced through that production scope we have as per India is concerned. Plus, I also have discussed that biotechnology has tremendous opportunity for the production of biopolymer or biopesticides, or that and also for energy generation, because energy is the very important that area that energy crisis we might be having very soon. So, naturally all scientists they are looking forward just to find out the different energy sources. So, biological process plays very important role. So, a lot of anaerobic digestion process that has been operated in the industry. And if you look at the foreign country like Germany, Sweden, they are operating the buses by using biogas. And India also, that we are operating some buses or vehicles, the 3-wheeler, 4-wheeler buses by using hydrogen, and hydrogen also can be produced through the biological means, also chemical means also can be produced. So, these are the scope of different industrial biotechnology as per India is concerned. And now, third question that raised by Payal Dasgupta, that please discuss the application of plots of enzyme kinetics, Lineweaver and A.D. Hofstee plot, how this plot benefit, how they can derive and where are they applied. Okay. That that is very nice, because let me tell you that that if you look at Michaelis-Menten equation, what is Michaelis-Menten equation? V equal to V max S Km plus S, am I right? Now, if you do the inverse, 1 by V Km by V max into 1 by S plus, I can write one by V max. Now, what is this equation? Because here this is constant, am I right? And this is constant. So, I can write this equation like this: y equal to mx plus c, am I right? And this is a pure straight line equation. It is a straight line equation, am I right? So, what I can do that that if I plot 1 by v versus 1 by s, we will be having straight line, and when we have the straight line, this slope will give you the value of Km by V max, am I right? And the intercept will give you the value of 1 by V max. Now, this V max value you can put in this equation in this particular slope, and you can find out the Km value. So, both the Km and V max you can find out. Now, there are two other plots are there. One is called A.D. Hofstee plot, a Hens and Wool plot, and purpose of this plot also same, that we have different type of that equation we derive, and we find out that the same constant, this kinetic constant of this value. Okay, now you raise the question of Hens and Wool plot. Let me discuss that. Now, Hens and Wool plot, how it has come? I hope you understand that. This is, you can let me write, this is V equal to V max, or we can write directly that Lineweaver-Bach plot 1 by V equal to Km V max 1 by S by 1 by V max, am I right? So, what I can do, I can multiply it by S both side, this is S and this is S, then this S will cancel. So, this is S by V equal to Km by V max plus 1 by V max into S, am I right? Now, here you see this is constant, am I right? And this is constant. So, this equation also similar to this is like this mx. So, this is constant c and this is constant m, and c x is the variables. So, here also if you plot SV by S plot like this, here also you will get a straight line. Only the difference is that the slope will give you the value of 1 by V max, and the intercept will give you the value of Km by V max. Now, it is just other way, Lineweaver-Bach plot, we found the intercept, we get the value of 1 by V max. Now, here from the slope we are getting the 1 by V max, then intercept we get the value of Km by V max. So, you put the value of V max here, you get the value of Km. So, your question is that it is more robust and error prone than line order barcode, that you have to work out. That you have to, because that in a true sense mostly we preferred the line order bar plot, because most of the problem we usually solve by using line order bar. In special cases or rare cases we use the Henson-Ulp or the Eddy-Hubsty plot. So, but you can try with all the process and find out what is the difference between the Km and Vmax you get. Now, next question is that that is from Ovinas Kale, that his question is that if fermentation produce less amount of energy than the oxidative phosphorylation, why bacteria prefer this mode of metabolism? Let me do the analysis. I hope this is a very valid question that you have raised, and we have small analysis on that. Let me show you this analysis. I hope you will be also interested. That now glucose, when you take it converted to what? Carbon dioxide and water. Am I right? So that EMP pathway, if we go through, then what you produce? 60 ATP. And a TCA cycle we produce 6 ATP. And when we go to oxidative phosphorylation, it produces 24 ATP. So, how much total ATP you will get? 36 ATP. Am I right? What is the heating value of 1 ATP? 1 ATP, the heating value is 7 kilocals, 7.3 kilocals per mole. Okay. Now, what is the total amount of energy generated? This will be 36 into 7.3. Am I right? This is kilocals. So, how much is this coming? It is coming about 1918 approximately. This is kilocals. Now, glucose, if we burn, because that it also generates the energy. But if we compare this energy with that heating value of glucose, this is around 44% of that. That is how much energy we can generate in the biological system. But your question might be linked with something else. That glucose we use for producing ethanol. Am I right? So, 1 mole of glucose produce 2 mole of ethanol. That is the thing that we have. Now, if you find out that the calorific value of that ethanol, it is about 6.9 kilocals per gram. Okay. Now, what is the molecular weight of the ethanol? Is 46. The total amount of heat produced in the form of ethanol is how much? That 6.9 into 46 into 2 kilocals. How much it is coming? It is coming around 634.8 kilocals. So, if you compare this and this, it is quite it is understandable, this is quite less, as this is your question. Now my answer to this question is that we look for this kind of energy conversion process. The reason is that one is that ethanol is very much required for, it has several uses in our day-to-day life, that is that demand is there. So, we try to produce this, we want to have this ethanol. And second thing is that it is renewable sources, because we produce ethanol from glucose or from starchy material which can be produced again and again. So, it will not be it is sustainable for a longer period of time. And third thing that is important, it is environmentally friendly. If you look at the carbon content in the ethanol is about C2, that means 2 carbon, and as compared to gasoline and other hydrocarbons, it is very low. So, if you produce, there is a less possibility of particulate matters in the air. So, that is why that is largely used. So, next question that I have, that is any innovative tools available for industrial, any innovative tools available for industrial biotechnology industry. I don't understand that, what do you mean by industrial tool actually, because whether it is equipment or it is analytical system or it is process design, what exactly you are looking for. Let me tell you a couple of things. I think that may satisfy you. That that as per tools is concerned, that our recent tools that has been developed in the analytical sector. As for example, glucose, I just now I was talking about how to find out the glucose concentration by using glucose oxidase. Now, this glucose oxidase can be used in the biosensor, you can use as a biosensor, and that can detect the glucose very easily. Whether that so that is used in the industry for the detection of glucose, and that can be detected instantaneously, because you should understand that what is the biosensor. Because I hope you understand, this biosensor are 2 units. One is biological recognition unit, another is your transducer. So, our the transducer is kind of electrical signal, that it may be amperometric, it may be potentiometric, maybe piezo, maybe any kind of that signal that we have. But biological recognition unit means it sense, because suppose I showed you the enzyme activity. So, if you have glucose oxidase, immediately sense the glucose, and that makes the some kind of voltage change in the sensor, and that then what you have microvolt or microampere, and with respect to concentration of glucose. So, you have this kind of change that we have. So, you can, if you have, so you can, from this you can find out what is the concentration is there, you can find out what is the concentration. The one is the biosensor, and second I can tell you the ethanol sensor, that is the alcohol sensor, that also used in the industry. And there are a lot of analytical devices that we have that is also required for the industry, for day-to-day operation, for ready estimation, and for some quick estimation technique we do that. I can give a typical example for citric acid industry. Now, for the citric acid estimation, it required 1 day. Now, if we take 1 day, now suppose you imagine you are running the citric acid fermentation process, and if you draw the sample and if the analysis take 1 day, after 1 day you have to take the decision that whether you are going to stop the fermentation or not. That is not possible. So, you have to develop some kind of quick estimation technique. So, all the industry they develop the quick estimation technique, like citric acid industry, they develop this simple by titrating with sodium hydroxide solution, and where you find out how much of that sodium hydroxide is consumed to raise the pH to up to 8.6, and they have a chart that if the consumption of this much, your total acid yield is like this. Now, total acid yield, that is collaborated, that is proportional to the citric acid concentration. So, if you citric acid yield, now if you find out this ratio, that if you citric acid yield and total acid yield, it might be varies from 90.9, this is 0.9 to 0.95. It is very close to each other, but only the advantage is that this will help you to take the decision very fast. But you can do the titration within 5-10 minutes. You can take the results and try to find out whether pH is decreasing. Because why? Because the citric acid is acidic. If the pH changes, that means that if the more sodium hydroxide is consumed in the titration process, that more acid formation is there. So, that you can conclude that more acid formation is there. Now, acid formation comes to the plateau, then that means the acid formation is almost stopped. So, then you can take the decision that let us stop this process now and go for harvesting. So, these are the couple of things that is very much important that we used to do. The sensor is, I told you, is a very important part that we have. Another important thing that we have in the fermentation industry, that is your mechanical seal, because in the fermenter, if you look at, this is the fermenter. So, that this is the agitator, am I right? So, you have to maintain the sterile conditions. So, here this is rotating, am I right? And this is what is this? This is the top plates. This is cover of the fermenter, and here you have nut and bolt. You can fix it. Now this is the moving part, and this is static. So, since one is moving like this, and so there is every possibility that air can come inside this like this. So, what you have to do, you have to make a mechanical seal, and this mechanical seal is specially designed in case of biochemical industries. And what is the speciality of this? Suppose this is the mechanical seal, and normally in the chemical industry they put some kind of packing material here, am I right? And they then pass the shaft like this. Now, here also we put the packing material, but besides that we pass the sterile antifoam oil. Because why we pass sterile antifoam oil? Because one advantage is that it subsides the foam, what is dripping down, and another is it lubricates the shaft. Since it is lubricating the shaft, then the heat generation in this mechanical seal will be very less, and it will help to maintain the positive pressure here. Since we have the positive pressure, then what will happen, that there is a less possibility of air to enter into the system. So, this is what we have in this particular things. Now, let me go to the some question that has been raised, that is Payal Dasgupta has asked that how to approach for a scale up process. Now, this is a very vital question, that how we do the scale up. Now, scale up, I think we didn't discuss this in our, that opportunity was not there actually, because This is a very specific, typical question in the area of biochemical engineering. Since you have asked this question, let me give the answer. Suppose in the biochemical industries, biochemical industry, they are mostly operated aerobically. Now, why aerobically? We understand the aerobic because the organism, microorganism, can take oxygen which is dissolved in the fermentation media. That you should understand. That they can take the dissolved oxygen in the fermentation media. So oxygen is sparingly soluble in water. Sparingly soluble in water. So major bottleneck of the aerobic fermentation process is what? Dissolved oxygen concentration. You can increase the glucose concentration, peptone concentration, other material concentration, because their solubility is very high, but solubility of glucose oxygen is very low. So what you can do that this oxygen transfer is usually expressed by a important parameter, what we call KLa. What is KLa? KLa called volumetric mass transfer. Coefficient. Okay. So KLa, we can find out. Now, when you do the scale up, suppose this is the small reactor. And this is the big reactor. Am I right? So, when you do the scale up, what do you have to take into account? You have to take into account the microorganism, whatever is growing here and here, their environment should be same. Environment should be same. So, you have to work in a manner so that that environment, because that living system, they are very sensitive to the environment. And that what we do in case of biochemical industry, we make the condition ideal for the growth of the microorganism. Am I right? So whatever conditions we have, we want to do here. Now how the question comes, how you can do that? That might be your question. So the one thing I told you, that one important parameter is the mass transfer, because the oxygen is sparingly soluble in water. Now that mass transfer, I can assume the KLa 1 and KLa 2, they should be same. This should be 1, because because same requirement you have to give. And for doing that, so how the different parameter changes, like what should be the starter speed, what should be the air flow rate, what is the power requirement of the starter, all these thing can be find out. So this information well documented in the book. If you go through the book, like Biochemical Engineering by Iba Humphrey, I can give the name. This is Biochemical Engineering by Iba Humphrey. Iba Humphrey and Millis. This book will give you the complete information, that how you can scale it up and all this thing. I hope it will be okay for you. And let me see that, while Dasgupta has another question, can we explain the condition of deep washout? Let me tell you, this is a very important question, because I am glad that you have asked that. Now, deep washout, let me tell you. You know that I told you that during my presentation, chemostat. Can you remember that chemostat? What is chemostat? Chemostat is nothing but CSTR. What is CSTR? Continuous start tank reactor. And how you can pictorially, how you can explain this? You can like this. There is the continuous info. Now, here I want to share with you that whenever we want to operate any kind of continuous process, first we operate in the batch mode, then we go for the continuous mode. Okay. The batch mode means let the reaction take place. When the reaction is maximum, then we go for the continuous flooding. So, here you have flooded and here you have flooded. So, here you have x0 value, you have x0 value, excuse me, that is SS and XSS, and this is also SSS and XSS, and this is V, volume of the reactor. Now, what is XSS and SSS? This is called steady state substrate concentration. SSS is called steady state substrate concentration. Now, let me tell you that what do you mean by steady state? That when we run this, continuously we are taking it out and we taking in and taking out of the liquid. So, we will find this substrate, this is the well mixed reactor, but so since this is the well mixed reactor, I can assume the homogeneity in the reaction mixture. So, whatever substrate concentration, whatever cell mass concentration we have here, same concentration we have with the outgoing stream. Now, when we operate that, what we will observe? That we will observe that substrate concentration keep on decreasing. Then after some time it will attain the plateau, and when it attains the plateau means your substrate concentration will be constant. When substrate concentration is constant, its cell mass concentration is constant, then we call it steady state condition. Okay. Now, if you plot XSS, SSS versus T, what you will get? This is like this, and this is, am I right? So, this point and this point is same. This is called XSS and SSS. Now, what is happening actually? Try, what is dilution rate? Dilution rate is the F by V. F is the flow rate and V is the volume. Am I right? So, what is happening? That as you change the V of the reactor liquid volume of the reactor is constant, but F you can change. If F you change, your D you can change. So, at different D, suppose you have different D value here, you have different X value and S value at standard steady state condition. Now, here you will find DSS, D washout. Why this occurs? Suppose here the F is the flow rate, F is the flow rate, and XSS is the cell mass concentration. What is the unit of flow rate? Volume per unit time. Am I right? And what is the unit of cell mass? Is mass per unit volume. So, the volume will cancel. This is mass per unit time. So, that means suppose that if you multiply that, that means that the cell mass always going out of the system. And if the cell mass that is going out of the system is more than cell mass that is producing inside the reactor, then what will happen? Suppose if your cell mass wasting from the reactor is more than cell mass growth, then what will happen? The cell mass concentration in the reactor will keep on decreasing, and a time will come there will be no cell present in the reactor. I hope you understand that. If cell mass that is whatever going out is more than the cell mass that is producing inside the reactor, that means cell mass concentration keep on decreasing in the reactor, and a time will come there will be no cell present in the reactor. Another explanation I can give you, that there is a term called generation time. What is called generation time? Time required for the cell division. The time required for the cell division. Am I right? Time required for the cell division. Now that in the when you operate the chemostat, you have D. 1 by D is what? Hydraulic retention time. What is hydraulic retention time? The liquid, how long it resides in the reactor. Now, if this time is less than the generation time, then what will happen? Before the cell multiply, you are taking out the cell from the reactor. So, naturally that you are not allowing the cell to grow in the reactor. So, what will happen? Cell, you will not find, say, after some time you will not find cell in the reactor. So, you should, until unless you give the sufficient time to the organism, then and only then they can multiply. Before they multiply, if you take the organism out from the reactor, then what will happen? You will find no cell present in the reactor. So, this I hope you understand, this is called cell D washout. Then another question you ask, what is the main reason for the secondary metabolites being produced in the stationary phase? I hope you should understand that, because you studied the BTech and MTech. Still you have a question, that is why I am giving this answer, that if you look at the life cycle, of the cells. What is the life cycle of the cell? It is like this. Am I right? So, you have different phases. You have lag phase, you have log phase, you have stationary phase, you have death phase. Am I right? Now, what is the definition? What is the significance of why the stationary phase occurred? Because stationary phase occurred because this is called starvation phase. What is starvation phase? Starvation means the organism has insufficient amount of nutrient for their growth and metabolism. And since they have very less amount of nutrient for their growth and metabolism, what will happen? Their physiology of the cell will change, and due to they will survive. They will survive in the harsh situation, and due to that their metabolic system that is changed, and that is why during that period we get the secondary metabolite formation. I hope you understand that. Now, there is another question asked by the Savita, that when the same method is used for the preparation of wine, how come the consistency, color, taste differ? How came the consistency, color, taste differ for each brand, and what are the factors involving in this difference. I hope you are concentrating on wine only, okay? When the same method is used, okay. Let me tell you. And that wine, how wine is produced? Wine usually produced from fruit juice. Am I right? So now, this is the organism we use, Saccharomyces ellipsoides. This is the organism that is used for the alcohol fermentation process. Now, after the fermentation is over, that what we have? After the fermentation, we have alcohol. But during the fermentation process, if you look at our metabolic pathway, it produces different organic acids, maybe in a very trace amount. That is why if you taste this fermentation broth just after the fermentation, wine fermentation process, after you will find very hot flavor. Now, if you keep it for longer period of time in the storage, then what will happen? This acid and alcohol, they will form the ester, and this harshness will go. So, you are talking about that, why the taste and consistency they differ. That if the quality of the fruit is the fruit juice is same, your organism is same, condition is same, and your storage time is same, your taste also should be expected to be same. But if any of the parameter changes, obviously your taste will vary. So, that is the reason, because again I am repeating that the old wine is very costly as compared to fresh wine. Why? But during the storage, the acid and alcohol, they form the esters, and esters, they help to develop some kind of good flavor. So, whatever harshness of the wine, that will go, and in place of that some smooth taste will develop. So, this is how the taste of the wine may vary from each other. Okay. Now, I have one question from Ritika Chaudhary, asks that please discuss the reactor analysis, especially the numerical part of what is CSTR. Okay, let me tell you. So, that reactor analysis of what I try to mention, that any kind of reactor analysis, we use one general formula. What is general formula? General formula is input plus generation, or equal to output plus disappearance plus accumulation. This is the normal equation that we have. Now, what we have, that that when you do any kind of mass balance of the system, that analysis of the system, reactor, this is reactor analysis. I am talking about reactor analysis. Now, when you do the reactor analysis, always we shall have to catch hold of one parameters and do the analysis. As for example, if you do the substrate balance, how you can do the analysis? Suppose I can write, you are talking about CSTR. So, let me give the sketch of CSTR. So, this is like this. There is a continuous inflow, there is outflow. This is F, this is S0, this is F, this is SS, and this is V of the reactor. Now, what is the input? The input is F into S0, but generation, no substrate is generated, substrate only consumed. So, we can write this is 0. What is the output that we have? This is F into S, SS. Then what is rate of disappearance? S minus RS into V. and rate of accumulation under steady state. What is steady state condition? When the concentration, this concentration, the substrate concentration will remain unchanged. Is steady with respect to concentration when it is constant. So, if it is constant, then when it is arise, when rate of accumulation this is equal to 0, then and only then steady state attain, it will attain the steady state. So, what you can write here, f is 0, I can write SSS equal to minus RS into V. Am I right? So, so I can write the V by F is equal to what? S0 minus SSS minus RSS. What is this? This is equal to V is the volume, and F volume, volumetric flow rate, volume per unit time, volume will cancel, this is time. And what is this time? This is called tau CSDR. This is called space time. Am I right? So, I hope you understand that how we analyze this process is very simple. You try with the different. I have given several problems, so you try it. I hope you can find solution of that. Now, probably this might be the last question. I don't know that. Please discuss the effect of mass transfer on immobilized enzyme kinetics. You know that. Let me tell you that when we have two type of system we have, one is called homogeneous, another is called heterogeneous. Now, when you talk about the immobilized enzyme, what is immobilized enzyme? The enzyme that fix on the solid matrix. Am I right? Now, as soon as the and your substrate usually remain in the liquid form. So, usually it is the insoluble mass. Now when that means when it is when it present in the liquid, then it is heterogeneous system. Heterogeneous means that more than presence of more than one phase, and here what are the phases you have? Your liquid phase and you have your solid phase. So, suppose this is a solid matrix and enzymes are immobilized on the other. This is called that adsorption technique. Adsorption is the simplest technique. Just enzyme this adhered on the surface of the solid matrix. Now, what is happening that when suppose here you have substrate, this substrate has to diffuse here surface of the enzyme, and until unless it go to the surface of the enzyme, substrate cannot react with the enzyme, and after the reaction is over, when product formation is there, product has to diffuse out and come to the bulk. So, this is the problem that we have, mass transfer problem that we have in the immobilized whole cell system. And this is we have two type. One is the external mass transfer. This is external. There is the internal. Internal means suppose there is a pore. You have an enzyme. This is solid matrix, and inside the pore your enzymes are there. So, naturally that when substrate goes, you have to go inside the pore. So, there the problem will be more severe, mass transfer will be more severe, and that can be determined with respect to parameter what you call eta, what you call effectiveness factor. Now, if the effectiveness factor is 1, that means it is we do not have any mass transfer problem, but if it is less than 1, now this is what is this? This is the rate of reactions, what do you call velocity of reactions, and velocity of reactions when SB equal to SS or SS equal to SB. What is SB and SS? This is called SB, and here's the substrate concentration at the surface of the enzyme, what we call surface SS. So, if this is same, then this will be maximum reaction. If this concentration equal to, we will have maximum, and this is actually SS. So, if it is deviate less than 1, that means if we as is reduces value, that means mass transfer problem will be more. As for example, suppose it is 0.5, that means very less, and it is 0.3, more severe. But if you have 0.9, that is close to 1, but 0.8 means the diffusion problem started like this. We can talk about the mass transfer problem. Now, another question that I have from Sobita, that are any material or reactor materials which withstand high temperature, which allow to gain more product from reactor to recent discovery. Are there any material and reactor which can withstand high temperature? I don't know that. Are you talking about the immobilized enzyme system? That if you talk about the immobilized enzyme system, I can give the example of solid matrix. If you use, it can withstand the high temperature. Now, if you talk about the reactor, that reactor material of construction in the biological system or in biochemical industry, mostly we use that stainless steel. We use the different type of stainless steel. SS31, we use SS314. This is 314 mostly used in the chemical industry. This is chemical industry we use, but usually in the biochemical industry we use the 316. So it is biochemical industry, and sometime we use SS317. I know that stainless steel means different metals, and if we add the different metals, the characteristics of the stainless steel changes. So that we can change. You talk about the high temperature, that only the metal can withstand high temperature, and other things I don't know, that we will have to work out with that. And last question is that can you explain the fermentation process involving mass transfer coefficient? Because rate of mass transfer, suppose rate of oxygen transfer is equal to what? Equal to KLA C star minus CL. But in case of biological system, as soon as you talk about the when growth of the organism is there, then this will be what? Then this will be QO2 into X. What is QO? So two things simultaneously occur. This is called oxygen uptake. Now oxygen transfer, sorry, this is called oxygen transfer, and this is called oxygen uptake by the cell. So that this is how we can analyze that. This is done because there is a technique called dynamic gassing out technique. By this method, you can find out the value of KLA. Thank you very much. That I hope I am able to tell that try to solve your question, and I wish you all the best. Thank you.